Hess's Law, Problem 2. I, Mr. B. Hess's law states that the total enthalpy change, or delta H, during the complete course of a chemical reaction is the same whether the reaction is made in one step or in several steps, where delta H of the reaction is equal to the sum of the delta H of formation of the products minus the sum of the delta H of formation of the reactants. Consider the following practice problem, where we ask to determine the delta H for the reaction where 4 moles of carbon monoxide, CO, reacts with 8 moles of hydrogen, H2, to produce 3 moles of methane, CH4, and 1 mole of carbon dioxide, CO2, and 2 moles of water, H2O. And we're given the following data, where A, 1 mole of carbon reacts with 1/2 mole of O2 to produce 1 mole of carbon monoxide, CO, with a delta H value of negative 110.5 kilojoules. Next, we're given the equation where 1 mole of carbon monoxide reacts with 1/2 mole of oxygen gas, O2, to produce 1 mole of carbon dioxide, CO2. And the delta H value for this reaction is negative 282.9 kilojoules. C. 1 mole of H2 reacts with 1/2 mole of O2 to produce 1 mole of water, with a delta H value equal to negative 285.8 kilojoules. Next, we have 1 mole of carbon reacting with 2 moles of H2 to produce 1 mole of CH4 with a delta H value of negative 74.8 kilojoules. And finally, 1 mole of methane, CH4, reacts with 2 moles of oxygen gas, CO2. Next, we have 1 mole of methane, CH4, reacting with 2 moles of oxygen gas to produce 1 mole of CO2 and 2 moles of H2O. The delta H for this reaction is negative 890.3 kilojoules. Now we must arrange the steps, the intermediate processes, to match the target reaction. So we flip equation A. This will cause the delta H value to go from negative 110.5 kilojoules to positive 110.5 kilojoules. Next, we multiply equation B by 3. This will cause the delta H value to go from negative 282.9 kilojoules to negative 848.7 kilojoules. Now we multiply equation C by 6. This will cause the delta H value to go from negative 285.8 kilojoules to negative 1,714.8 kilojoules. Equation D we do not flip, which means that the delta H value remains at negative 74.8 kilojoules. Now we flip equation E and multiply by 2. This will cause the delta H value to go from negative 890.3 kilojoules to a positive 1,780.6 kilojoules. Now we must cancel the intermediates and add like terms. Let's begin by canceling the intermediates. Carbon cancels in equation A and D. 1/2 mole of O2 plus 8/2 moles of O2 is equal to 9/2 moles of O2. 3/2 moles of O2 and 6/2 moles of O2 is equal to 9/2 moles of O2. So the O2 will cancel. Now we add like terms where on the reactant side of equation A we have CO. And on the reactant side of equation B we also have CO. 1 CO plus 3 COs is equal to 4 COs, or carbon monoxide. 3 moles of CO2 minus 2 moles of CO2 is equal to 1 mole of CO2, where 3 moles of CO2 is found on the product side of equation B, and 2 moles of CO2 is found on the reactant side of equation E. This means that the 3 moles were consumed and the 2 moles were produced. Six moles of H2 plus 2 moles of H2 is equal to 8 moles of H2. And 1 mole of CH4 plus 2 moles of CH4 is equal to 3 moles of CH4. Now the intermediates have been canceled, which leaves us with the following results, where in equation A we only have carbon monoxide, CO, with a delta H value of plus 110.5 kilojoules. In equation B we have 3CO yielding 2CO2, with a delta H value of negative 848.7 kilojoules. In equation C, we have 6H2, which yields 2H2O, and the delta H value is negative 1714.8 kilojoules. And in equation D, we have 2 moles of H2 yielding 1 mole of CH4, with a delta H value of negative 74.8 kilojoules. And finally, in equation E, we have 2 moles of CH4 with a delta H value of positive 1780.6 kilojoules. Now we add up all the kilojoules, where 110.5 plus negative 848.7 plus negative 1714.8 plus negative 44.8 plus positive 1780.6 is equal to negative 747.2 kilojoules. This concludes my explanation of problem 2 of Hess's law. I'm Mr. B. Thanks for watching.